two questions here, an A question, a B question. And we're going to work through this. This is on composition of functions. And also it's going to ask us whether they're inverses of each other. So find the composition f of g of x and g of f of x. I like to put these in color. So f of x, we'll do f of x as blue. So this first one, notice is going to be f something, and g of x is what gets put inside it. Second one is the g's on the outside, so this is g of f of x. Blue, in both cases, the g of x in red in both cases. And we've got to find them, and we'll put them in here. They will be inverses of each other if both of them equal x. And the reason that is, well, as we go through it, each function starts at x, right? We're plugging x into a function. And if we plug it in and go through the process and we end up back where we started, that means these are inverses of each other. One does something, the other undoes it. And if they're both equal to just x, because we started at x, then those are inverses. Anything else, and they're not. So let's take a look. So first part for A, we're doing, well, actually we've got to do it for both, right? So f of g of x. We're going to take, so for this first one, f is on the outside. Colors, right? Start with the blue. It's on the outside. So that's the receiving function. So we get the receiving function ready to have guests, right? So this is x over 6. What that means is that the input, what I'm doing is saying that, well, instead of writing x, let's make a new symbol of just an open parentheses. Okay, so this is x over 6. What goes in that parentheses? The g function. That goes up here. So now at least I've got the composition correct. I've plugged it in correctly, and then now we simplify. So yeah, there's nothing outside here, no squaring, so I can really just ignore the parentheses, take them off. We've got 6 divided by 6. All that's left is x. Okay, so this first one, we found that when we did the composition, we get back to x. Right? We started at x. Started at x, we did put it into g, and then we put it into f, and we're back at x. So now let's see if that happens in the same way with the other function. We're starting with g. So we take the g function, we rewrite it, but instead of writing x, this is 6x, but we put our new symbol, big open parentheses. What goes in that parentheses? Function f. So that's x divided by 6. Now we can simplify. So the parentheses are there to imply multiplication. We can think of the outside 6 as being 6 over 1. So 6 divided by 6 is 1. 1 times x is x. So this one also ends up being x. So when they both compositions, one into the other into the one, ends up being x, these are what are determined to be inverses of each other. Okay, so they are inverses. And what you can kind of see as we look to the next one, inverse functions, they have inverse operations. So I can kind of see that probably this one's not going to be it. Now this I'm multiplying by 2, I'm dividing by 2. Those are inverse. But here I'm adding 3 and adding 3. I don't think this is going to work out to be an inverse function, a pair of inverse functions, because I don't see this inverse. Now, had one of these been a negative, I could probably be convinced, we'd probably find out this is an inverse. So f, we start with the outside function for this one, right? So we're going to take 2x plus 3. and x is just a big open parentheses. What goes in that big open parentheses? The whole function of g, x plus 3 over 2. And now we can start simplifying. 2 divided by 2, right? That's going to cancel out and give us 1. So we have x plus 3 plus 3 more. That gives us x plus 6. That's not just x, it's x plus 6. So we put that in, and for that particular case, we can say these are not inverses. Now, even if the second one ends up being x, which could be, I mean, could, it's not going to work. Okay, but let's go ahead and do the second one because we have to, right? We start with the outside function of g, so we're going to take g, x plus 3 over 2, and we put it like this, x plus 3 all over x plus 3 over 2. What goes inside there? The 2x plus 3. So following order of operations, 2x plus 3 gives us 2x plus 6 over 2. Now you can divide the 2 into each of these. This is going to be a key part, or just, through distributing. So we get 2 divided by 2 is x. 6 divided by 2 is 3. X plus 3. Still not equal to just x. But each of these answers is different. Get it up here, just making sure. Yeah, it's going to be good. X plus 3. And that's composition functions to find inverse functions, or whether they're function or not, inverse or not.